Morning. Welcome, and hope you've had a good couple of days here. So what I wanted to do this morning was, first of all, just introduce myself. So I'm from VMware, and I run our Telco business group at VMware. And VMware, as you know, is a virtualization software company, and we're looking at the telecom market and the evolution of this landscape pretty closely because we believe that there is a significant transformation occurring here that just is super interesting to all of us. So I'm going to spend most of my time here talking to you about this particular opportunity that relates to the creation of a new cloud. And I'm going to focus on the optimistic side of what's to come, because a lot of what I hear about when I talk to service providers, communication service providers in particular, and telcos, is a more, I'd say, sort of depressing and pessimistic story. It's around decreasing ARPUs, it's around increasing network cost, and it's around not being able to translate this really to business profits or profitability. And so most of the business is focused either on consolidation or on cost cutting. What I believe is a new opportunity is in the making, and for all of the communication service providers that are ready to jump onto this, this is the right time to doing that. So with that, let me kind of start off with something that is a little provocative, which is every time we talk about cloud, the most kind of common names that come to people's minds are companies like Amazon, Azure, Google, IBM, and then if you extend that to companies like OVH, Ali Cloud, and several other clouds. But these names are prominent and in the forefront among everybody who thinks cloud. Telcos and communication service providers don't come as prominent names in that cloud. So real question is, have the CSPs missed the boat or missed the train in terms of where the cloud is heading? And fundamentally, we feel like while that is true in terms of the hyperscale, concentrated public cloud architectures, there is a new cloud in the making. And for the folks that are essentially kind of here and now and on the ready in terms of jumping onto this, this is the right time to get aboard this new cloud. Now, let me kind of start talking to you a little bit about applications and how the application landscape is going to change for the future, because this is going to be pertinent to what the underlying cloud infrastructure is going to look like or what it needs to look like. So take the example of what I would claim is an app that is going to be commonplace maybe a year or two from now. So what you're seeing here is essentially a picture of remote surgery in terms of a medical professional being able to operate on somebody remotely. Now, some of this is available today, so this is not necessarily future, but what I am postulating is that an app developer is going to have access to him or her tools and capacity that they can consume in order to build an application that is this sophisticated, that would include the components of standard application building as well as virtual and augmented reality, the ability to insert, for example, robotics into this thing, and be able to do this from a distance that is far removed from where the actual action is taking place. Now, which cloud will such an application be built on? Would this be built on an Amazon cloud? Would this be built inside a corporate data center or a private cloud? Would this perhaps consume some resources that a telco or a communication service provider or a cable company might provide? So if you start kind of asking questions like that in terms of the landscape of evolving applications, it's going to start telling you that the cloud landscape is going to need to transform in order to support applications like this. That what you see today is not going to be the cloud landscape of the future. Let me give you one more application example over here. So every time people talk about Internet of Things, IoT, connected cars are often used as an example of an IoT application. What I want you to imagine is, in fact, being in a car a year or two from now, where the traffic information that you might get would be extremely sophisticated. So it's no longer just kind of Google Maps displayed on your dashboard or Waze. What you could potentially have is the ability to essentially have complete information of every car that is on the road around you, knowledge of the driver's kind of skill set and capabilities, a learning algorithm that goes in and understands where each driver is likely to head to based on the patterns of what they have been doing over the past history, and then being able to accumulate all of this to give you completely accurate information on exactly what is going to happen in terms of the traffic pattern that you are about to sense. So as you can see, an application like this will likely involve a combination of just standard data processing, machine learning, and the ability to instantly communicate back and forth. And all of this needs to come together in creating an app like this for the future. What cloud will that reside on? Will that be on an Amazon cloud? Would that be on a private cloud? Or would that perhaps be on a telco cloud? Now, before I actually go to answering the cloud question, let me also say that we are generally quick to take technology as the answer to many problems. But in fact, if you look at the CSP opportunity that I am describing, there is a very fundamental business model element to this as well. Primarily, if you look at companies like Netflix and WhatsApp that are traditionally or kind of classified in the OTT class or over-the-top providers, if you look at companies like Salesforce and Workday or Microsoft Office, there's a whole bunch of SaaS business models in play today. And then if you look at companies like Google and Facebook, they are all ad-supported revenue models. The reason I point this out to you is because many of these companies are, in fact, operating what they do today on top of an infrastructure that is provided by you as communication service providers. But the difference is that the business model variation that they are able to leverage on top of your infrastructure is immense. And so I would say that the transformation that is going to happen is many of these business models are going to potentially be adopted or have to be adopted by you in order to turn the trend around to make this a profitable business model for you. So it's not just sufficient to go in and participate on the right side of this picture in terms of new networks and clouds. You actually need to know exactly how you're going to take advantage of the left side of this picture. So with that, let me actually spend more of my time now talking about what I would see as this kind of new network and cloud in transformation. So fundamentally, I'm going to describe to you this sort of three-cloud world that I started talking to you about. The private cloud, again, just to be very clear, is a pool of capacity that combines compute, storage, network, and management that is available within a corporate data center or a firewall, and that is accessible by today's IT in order to build and deploy applications. The public cloud, in contrast, is essentially a remote, multi-tenanted, hyper-converged, often, data center that is essentially clustered capacity in one geographic location that is available to multiple customers to consume in some form of a SaaS or subscription model. What I think you in this room and other service providers globally have the opportunity is to create this third green cloud. And this CSP, or the telco cloud, is going to be a highly distributed cloud architecture that essentially takes advantages of the multiple points of presence and the asset base that you have, whether that is wireless spectrum or wired telephony assets or a combination of the two. By design, what you have is a distributed infrastructure. And if you can take that and you can transform that into a cloud that can be accessed by devices wherever they are, that to me is the opportunity that you really need to know how to leverage and monetize. Now, there are a couple of fundamental technologies that this conference itself is based on. Not surprisingly, NFV and SDN, that I'm going to spend a few minutes on, because these are core tenets of how we believe that virtualization is actually going to play a significant role in the evolution of this cloud architecture, particularly with the advent of 5G. Let me start off just quickly with a very simple picture of NFV. And as you can see, fundamentally, it's the ability for us to take something that has historically been developed and deployed in a hardware form factor, in a very sort of rigid form factor with very little flexibility to go change, to now convert that network function into a software-defined and software-delivered alternative. The first phase of that is really decomposing your network function into the subcomponents or component functions and delivering that on an infrastructure which typically has a compute storage network infrastructure plane. On top of that, there's a virtualization manager, an orchestrator, and then you deliver the network functions on top of that. In order to make this something useful, you have to be able to orchestrate a few of these network functions together to deliver it as the end-to-end service that you're looking to deliver, which, as many of you are familiar with, as well as heard probably several times in this conference, you can deliver that as a virtual EPC solution. There are IMS solutions. There are solutions that are delivered to the endpoint or to the branch in the form of customer prem equipment. And that then becomes sort of a complete NFV architecture. Now, the reason that I wanted to present this is, if you remember my 3-cloud picture, what if this architecture essentially is extended to all 3 clouds? The reason that that is important is because 2 of those clouds already have been there for the last, the private cloud for the last maybe 15 years, and public clouds for the last 5 years. And so as a result, this is not a start from scratch effort. All you are doing is kind of taking that green cloud and adapting it to be somewhat similar to what the other 2 clouds are, so that you can, in fact, connect or attach this to the other clouds and make this a single substrate or single infrastructure on top of which you can build new applications. So as you see in this simplified picture, you could now conceptually imagine that there is an NFV CSP cloud, there is an IT private cloud, there are public clouds, all of which have essentially a layer of management and orchestration that layer on top of that, and then become the basis on top of which you can land both virtual network functions as well as applications. And you can do this both in a traditional existing legacy format as well as in a cloud-native container-delivered format. So this would be essentially sort of the nirvana picture from a developer standpoint, because now think about it. If I am the developer and I'm building an application, then I have access to this infrastructure. I just go in and build my remote medical application or my IoT application without having to worry whether the capacity underneath is compute or storage or network, and whether it's coming from private or public or a CSP cloud. Now, fundamentally, if you look at what 5G is about, there are a couple of things that are associated trends. One, when 5G becomes production ready, which is essentially in the next year or 2 or 3, you're also going to have this real explosion of the number of endpoint devices that are often talked about in the context of IoT. And so what I have shown here is a simple qualitative picture that shows you that if you are operating in a non-virtualized environment, you're going to have the ability to sustain a certain amount of device count as the devices at the endpoint that you can manage. Whereas if you look at what 5G is about, if you look at the densification of the network, the ability to have essentially more cell towers, more base stations, the ability to go in and communicate in a more granular way and in a more distributed architecture, then that requires virtualization in order for you to be on that top light blue curve that you see out here. Simultaneously, if you think about what the edge nature or the distributed nature of the data center itself becomes, this is one where every central office, every base station, and you've kind of seen, obviously, initiatives like Cord. You've seen initiatives like mobile and multi-access edge computing. The basic idea here is that 5G comes with cool concepts like network slicing. The idea is that you will now have a bandwidth pipe that you will be able to chop up and make them essentially use case specific in terms of the capacity that they deliver. So people talk about, for example, an IoT channel, a VR and AR channel. Now, it's not sufficient to just take that bandwidth and chop it up and make it into those channels. What you need is, at the ingress and egress, you need points that can actually consume that capacity and maintain that purpose-specific channel so that you can actually have end-to-end fidelity of a service from one end to the other. And in order to be able to do that, you have got to be able to take your virtualized capacity and target that virtualized capacity at those channels that are being distributed across the 5G interface. And so this is very similar to being able to take your central office or your base station architecture and completely distributing that into a set of virtualized micro data centers that often will be distributed across all of the operating company domains that you have under your purview. Now, the other technology that I want to spend maybe a minute on is SDN, or software-defined networking. And one of the best additions of SDN into this network is to address the question of security. Because so far, what I have talked about is the ability to create new cloud architectures that can deliver next-generation applications. But as you're doing that, remember that you also have to remember that these applications need to be secure. So how does SDN help in terms of security? So think about the picture that I've just shown you. It's essentially this cloud architecture that I just described, but it is serving up a slightly more traditional application, a 3-tier application with a web front end, an app middle tier, and a database back end. Introduce into it a virtual network function, and think about now your next generation application as being a cluster of all of this capacity. Let's just say this is delivering your new IoT application, and let's say that application is transiting or traveling through in one of these custom-specific channels that have been created in your 5G network. That's the scenario here. How do you secure such an application? If, in fact, what you have done is built that application with an SDN architecture underneath that, then what you can do literally is, through software, you can create a boundary that just encompasses the pieces of that application and make sure that you can ensure security within that software boundary. And then you also have the flexibility to change that boundary just through policies that can be stated over software. So this is the advantage of an SDN architecture. So in closing, what I want to be able to share with you is essentially this optimistic picture of the future. So like I said, you've got the left and the right clouds already on top. The green cloud is in formation, and you're right now in the process of actually being a participant in that. And assuming this comes into being with technologies like NFV and SDN, what you are going to be able to do is essentially have a multi-cloud API interface that allows developers to go build their applications, make them agile for the delivery of services, have them be deployed rapidly, and finally be intrinsically secure. So hopefully 2 years from now, we'll be looking at this and saying that's legacy. Well, thank you.